All right. So this is, I guess, day 2 of trying to build a Regex engine. So nothing major has changed. I just organized the code to be a bit cleaner, like separated. The parsing package is in one directory, and I've made a matching directory as well. So parsing is purely for building the tree, the parsing tree. You've got the structures, everything's public in the structures, and you've got the parse function and the print function and the cleanup function, and then of course to parse like lower level ideas like parsing or expression, sub-expression, those are private, so those are just in the source code, they're not in the header files. And then all the definitions that were in the original C file, I've moved them across to their relative appropriate files. So I've got like a few source files, a few header files. I had a main file to like test things, but I've commented it out because I'm moving on to matching.c. So this is my new main file, main function. And basically, it's a mild setup. All I'm doing is I'm making a program, takes in a regex expression, takes in a string, like text string, and my thinking right now is pass the expression using the function we made before. I can print it as well, and then I think I should also have the length of the text. I'm not sure. Oh wait, I forgot to string page. Oops. Yeah. So yeah, I think I'll need this. I'm not sure. We'll see. And then of course clean everything up. So that should compile. See if I do. What do I need? Let me move into matching first. So if I do, and then also, yeah, that compiles, good. So that'll be my command for now. And then if I run it so if I don't do anything, I should get a usage error. And then if I should put a bash section. And then if I run it with like some random pattern and some random text, for now all it does is it figures out the tree for the pattern and does nothing else. I haven't done any matching yet, but I want to go through. I feel like I'm not super confident in like understanding how this is going to work. So I think I'll start with a few really simple examples and draw them out like completely and go from there. Do I have, yeah, so I was doing a lot of like random drawing before, but I'll start again because I think I didn't really gather my thoughts very well. All right, let's just start fresh. So my goal for today is as follows. I have input the regex pattern and also the text string, and my goal is to produce my output should be Boolean. True means the regex pattern. I was contemplating on whether it should be either partial matches or full matches. I'm going to say it has to be a full match. Completely. Sorry, the caps messed me up. Matches the text string, and then false otherwise. So, as some examples, if you have make a little table for true cases versus false cases. If you have like ABC for the regex and then ABC for the pattern, so regex, maybe I'll do it like that, regex pattern, text I mean. So yeah, if you have like the same thing twice, that should be true. If you have like A, B, C star, and A, B, C, 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 that should return true. If you have like A, B star C, and then only AC, that should return true because B star, remember, star means 0 or more. So that can be 0 or more B's in this case. You got some bracketed stuff, A, B or C, D. You can have like A, C, D. That matches because it has to be A, and then either B or C should be in the next place, and then D. So there's a few examples, and then you can have like B, C, whole thing star, A, B, C, etc. Right? Whatever. False cases can be like if there's like a random letter that shouldn't be there, like A, B, C, D, and the text is only A, B, C. And then the other way around, you could have A, B, C, D, and like A, B, C, D, E. So this, to be fair, this is a bit of a point of contention, I think, because if you think about it, and if you think about like the Control F example I was talking about last time, the Control F would sort of match the ABCD inside the ABCDE. And so you could argue that this should actually be a true. And maybe I will change the behavior to do that later on. But for now, just for the sake of consistency and having a clear goal in mind, I'm just going to say that if it doesn't completely match the entirety of the text string, I'll call it false. Which, yeah. And then you have like A, B, C star, C or something. That means that there has to be at least one C because C star is 0 or more plus an extra C, but you only have an A and a B. That's a problem because you need to have a C. And there's a bunch of others, I'm sure, but yeah. Okay, so before we get coding, because I feel like I like my tree. I like my tree. I think the tree is a good idea. It just feels like a sort of the kind of pattern you would use for this kind of thing. But I'm not 100% confident in actually traversing it because I feel like the structure I've sort of designed for it is a bit long-winded, and the void thing I did, I'm like starting to contemplate on whether that was a good idea. Probably wasn't, to be fair, but what can we do? Well, we could change it, but I'm probably not going to. It's the capabilities of this regex is simple enough that, or basic enough that I should be able to get away with it. But I do want to do a few examples of like how I think I should traverse the tree. So especially with the brackets, because I think the brackets make things quite complicated. Brackets and pipes will make things really weird. Stars as well, but I feel like to a lesser extent. So here's my thinking. Let's say, I'm just going to work through a few examples. Let's say, for example, you have a regex that looks like, let's just say AB, and there's text that's AB as well. Okay, nice and simple to start with. So the tree that gets generated, and we can actually test this, but that's the beauty of having this done. If I don't care about the text just yet and just look at the string, look at the tree, sorry, we can kind of confirm this, but the tree will look as follows. You'll have the overall expression node, which breaks down into a sub node and an OR node. The OR node in this case will be empty because there's no OR pipe in as part of the expression. The sub will have sort of its letter. There's the block and there's the single char and everything. Eventually, it will just boil down to just be an A, and then there'll be another sub, and this sub will be a B. Eventually, again, there'll be more details, and then there'll be another sub, and this sub will be empty. Remember that sub has an empty field, is empty field. Sub expression has an is empty. So if there's no more subs to do, then it'll just set that to empty. And so if I look at my terminal, you'll see kind of that sort of, why can't I scroll? Oh. There we go. Okay. Sorry. So you have the expression, first child, and then second child is OR. That's what we have. Sub and OR. So like if I was to label the generations, this is 1, this is 2, 2. It's hard afterwards, but this would be 3. This would be like some other number. This would be 4, I think. This would also be 4. Oh no, this wouldn't be 4. This would be 3, this would be 4. So yeah, 1 sub expression is 2, OR expression is also 2. Then you have, repeated block, because for stars, it's important for me to know have a repeated block. Then the block, single char, it's an A, that's where the A comes from. And then bubbling back up, you have the other sub expression, which is number 3. Repeated block, the B, right? That's what this guy is on the left side. On the right side, you have the other sub expression on generation 4 sub expression, but this one is empty, so it doesn't have anything underneath it. And then, yeah. So this is the tree. So bearing in mind that the text looks like this, how would I undergo a match? Well, in my mind, I would call, match between this particular tree given this particular text. And what I would do is I think I would need some kind of pointer pointing to sort of the start of the text pointer. So maybe I'll write it bigger. This is my text, and this is my pointer. And I'll probably have the lasso ready to go. Okay, so yeah, I'll call the expression, and I'll say, hey, does the expression match with the text? So I'll say, okay, let's look at the first sub expression. What does that entail? Well, it's an A by itself. So I'll check, does that match with the A over here? And it does, right? So why does it keep going back to the pen? I don't want the pen. And that's great. So I think this should shift down, and we should move on. We should go to the next. From A, we should sort of travel to the next person. So it's kind of like, it's giving the vibes of like a post-order traversal, figure out the kids first before you move back to the parents. So, figure out A and then look at B. Does it match? Yeah, it matches. Fantastic. And then maybe move the pointer down again. It's pointing to like the null terminator or whatever. Go to 4. Oh, that's an empty string. That's cool. And this is also empty. So, on this side, this subtree basically managed to match the AB pretty fantastically. So we'll go back, this should somehow this should bubble back to expression and report true. And so because this returned true to expression should be like, I don't even care what the OR says, this already said true, so it's done, 100%, no worries. So that's like basic example. No wildcards, no special characters, no nothing. If we talk about the OR, if we imagine like something like this, what if the text was like, so let's say same kind of example. So this is example 1. Example 2 is like, let's say regex is CD or AB, and the text is the same, AB. Right? So it's the exact same text, with this pointer, but the tree will change, and we can again just do a little bit of this. Hopefully this works. To be fair, I don't know if I really tested the pipe, actually, now I think about it. Hopefully it worked. Yeah, a lot more complicated, a lot more quickly, because this OR expression gets filled in a bit more. But without looking, I think it would be something like this. Expression, you have the sub-expression and the OR, and I'll try to give myself a bit more space because I'm going to need it. So this is the sub-expression, and then you have the OR expression, which has 2 kids. Wait, 2 kids or 1? Is it the structure, does the OR just have an expression node? Expression child? What am I doing? Drag down, please, thank you. Yeah, sorry, it just has 1 kid. It has another expression, which might seem a bit redundant, and yeah, my that's why I think my tree structure is a little bit strange, but it's just so that I can have another OR sort of in a recursive fashion, and this one will be empty. So yeah, so this sub has 2 kids. It has the, how was I doing it? Okay, so this sub will have the C followed by a sub, and then a D followed by a sub, which is empty. And that's like the CD part. And then you'll have sub, which is the A, and then another sub, which has the B, and then another sub, which is empty. And that's like the AB. So CD on this side or AB on this side. So what should happen this time is we do kind of a similar idea. Expression, we sort of bubble through here. We say, hey, does the first person match with the first person? And the answer is no, right? The answer is we do not have a match between here. So this guy should immediately report false back. In fact, let's make it a bit more interesting. Let's say it's AD, not CD. Let's say this is A. So AD, which means this would change by making this an A. So in actuality, you know, we bubble down to here. We say, hey, that matches. You know, the pointer, what the pointer is pointing to, and what this letter is saying is, yeah, it's an A. So let's move the pointer down and ask the same question for the child. The next sub. Does that match? No, it doesn't. So that's a problem. That's not going to match. So you should sort of bubble back false, and you should bubble back false. Because there was not a match on this side, we should reset the pointer back, I think, to A. And yeah, because this guy saw a false on this side, it should check the OR. Let's try the OR. So we will we'll match the OR side, which in turn will ask the expression, which will then basically redo what this guy was doing, but on this side. You know, check your left. Does it match? Yeah, it does match. So let's move the pointer down. And then move across. Do you match? Yeah, I do match with the B, right? The pointer. Move this along. And then, you know, this guy becomes empty, but this is the empty string, so that looks pretty good. So this guy will sort of bubble back and say, yeah, true. And because this side says true, we don't care what's on this side. You know, an OR isn't going to make a difference for a true result. This guy returns true. So even though we got a false on this side, we got a true on this side. So this guy should report, hey, we got a true result. That's the basic idea. And that's why I feel like this tree is really useful, because the recursive nature of this like string checking makes the tree like really helpful. But I just don't know if I'm a little bit, I think the OR result is quite cool. I'm a little bit paranoid about stars, especially in brackets. Grouped stars, like groups of like bracketed expressions followed by a star, I feel like will be a bit of a pain. But let's see. So let's do another example with another one of these features. So let's say you have regex, and then you have like A, B, star, and I'll put another B, because I think that's one of the things I'm scared about. And then text, let's say it's A, B, 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 D. Okay, so now just looking at it by inspection, what should happen is this A should match to this A. This B star should match to just the first two B's, not all three. This B should match to this one, and this D matches to this one. My thinking for now is that I think the B star should match to everything, it should attempt to match to everything. And then when this B can't match to anything, this B star should backtrack so that it only matches to two things, and then this B will have something to match to it. You know what I mean? So that there's like a kind of try to match as much as you can, and if it fails, sort of match one less and try again. So there might be cleverer ways of like doing that, but we'll see. So yeah, let's do this real quick. What did I say? A, B, star, D? I don't know why I skipped C. That was a bit random. Anyway, this one's not too bad. So the way we sort of mention the fact that there's a star here is, you know, we have our expression node, our root expression node. We have OR on this side, where this OR is empty because there's no OR. Then you have the sub, which has A, and then another sub, which has B, but the B will have a star associated with it, and I'll show you what that looks like exactly. And then there's another sub, and then there's D, and there's another sub, and that one's just empty. So just to show what the star will look like, you'll have the expression. You know, you have your sub, put the numbers in. This is generation 1, 2, 3, and 4, and 5 as well. So generation 2 is that first sub, and you'll be able to access the A eventually, right, through here. Then you have you notice there's a star, but there's nothing sort of written with it. It's just a star. It says star by itself. Then you have expression number 3, sub-expression number 3, which you can see, like we can see the single char B, but notice this time there's a star, but we actually have dash dash star, like an arrow and then a star written there as well. The reason for that is because when passing the star node, has an is empty field. If that's set to true, that means there's no star involved. There's no star associated with this sub-expression. So in this case, is empty was set to false, which is why a star has been written. So I'm able to figure out if this particular character, or sometimes group of characters, has a star associated with it. And that's what that's telling me. So I can, from a sub-expression, I can figure out, what character is there, and also is there a star associated with the group. And number 4, single char, and you can see the star has no asterisk written with it. So it's just a D by itself. And then 5 is the empty sub-expression, that's why there's nothing beneath it. And then 2 is the OR expression, which is empty and that's why there's nothing beneath it. So that's the tree. And then the question becomes, how would I sort of, naively, how would I do this matching? Well, again, A, B, 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 D with a pointer. So the expression here bubbles down to sub. We see the A, and we say, yep, that matches. No worries. Let's move the pointer down. Now the star in the next part, we bubble, we try to go down to the next part of the tree. And we say, hey, there's a B, but it's a B star. It's not just a B by itself, it's a B star. So what should I do? Well, the B does match once. And instead of moving on, we'll move the pointer down, but instead of moving on in the tree, we'll try again. Does the B match again? Yeah, it does. Does the B match again? Yeah, it does. Does it match again? No. Okay, but we found some matches. We've moved the pointer sort of an appropriate number of times. Let's keep going. Wait, I missed something. I forgot the extra B. Apologies. There should be a B in the tree, one more B. And then there should be a D, and then sub-empty. Because that's what the original example was. In the actual program, I also failed to type it correctly. There we go. So that'll reflect the same changes. You can see there's a B with a star and then a B without a star. That's what this is showing. So anyway, otherwise the example is the same. So yeah, we matched the B star and we matched it everywhere. Then we keep going and we try to match the B and we say, well, does it match? Not at all. Right? We've got a B here. It needs to be there because there's no star. It needs to be there. There's a B there. And then there's a D, which doesn't match at all. So what happens? Well, I'm assuming at this point, after I've done my complete matching, I should be in some kind of loop. And when this fails, I'll backtrack to here and say, okay, that failed. Let me try decrement by 1. And I think what's important is I remember the original index. I remember the original index where the B star started. Why is the pen not? Give me the pen. There you go. So this dot that I'm putting represents where I started matching the B stars. Okay? And I think I can do another example to show why that's really quite important. Anyway, we move it back 1 and we try again. So we've gone back to say, hey, it failed, false, whatever. So it will decrease the pointer by 1. I didn't actually do that. So we'll shift this pointer back. Oh no, sorry, it was pointing here before, wasn't it? Sorry, it's pointing here now. Yeah, that's fine. And try again. Go try again. So we'll travel again. Does it match? Yeah, it does match. B to B. Fantastic. So let's move it down. And does the D match? Yes, it matches. So move it down. Then empty sub matches the null terminator. So happily responds true, and then you'll bubble back, say true. You'll bubble back, say true. So once this sees true, we don't, whatever this loop or whatever I'm thinking of, it will break out or whatever. And then, you respond true, you respond true. And because the expression sees true on the left side, doesn't matter what's on the right side, report true. Right, so we've got this idea of a loop that decrements number of what I call starred matches. I'm a bit scared because I feel like the more stars you have, the more loops you have, the more sort of nested, and it's this is a very nested program where you can have loops and loops and loops. I won't write loops and loops and loops, but in terms of the runtime, you could have 1 B star sort of backtracking slowly, and then later on you could have a C star that's backtracking slowly, and a D star back, and that could be happening within each other. You know, the B star could be happening, and within that B star, the C star is happening. And I just feel like the time complexity can get very crazy very quickly. But I also think that it's not like I'm going to be doing this on using this app on like crazy massive applications or anything. So the regexes and the text I'll be testing will be quite small. So I don't think I'm going to have a huge problem, but I am curious to see how these processes get optimized properly, because I'm being quite naive right now. I'm sure there are algorithms that can be used. Okay, so let's say an example where the B star isn't actually useful. What do I mean by that? Let's take the example which was like this one. So A, B star, C. So the regex is A, B star, C, and the text is purely AC. So, like I said, B star can match 0 or more Bs. So if there's no Bs, that's fine in terms of matching. So yeah, the text is AC. I don't think I need to use the tool anymore, or use the program anymore. I think we can just about write it out. We have the expression node, you have the OR node, which is empty. You have the subnode. The subnode will have its letter associated with it, as well as another subnode, which has the B and the star associated with it, then another subnode, which has the C and another subnode, which is empty. We'll say it's empty, which is cool. Now, what happens? The pointer starts here. Wait, no, I don't like the example actually. I want to show why this is important, but I don't think this will show that. Oh, I got a good idea. I know how to register. Let's say there's 2 more B's in the let's say there's 2 more B's in the regex and 2 more B's in the text. So B, B, C. Okay, good. So then you have expression. You bubble through. Does it match? Yes, it does. Move the pointer down. Now this is where things get a bit tricky. I have to change the tree actually. Hang on. So you have another B and another B, and then finally a C, which in this guy is empty. Okay, so yeah, sorry. This guy bubbles down, sees A, move the pointer down. Okay, then this guy sees a B star, and what I said was I will match it as many times as I can. So I will use the red dot, keep track of where we started, where the pointer started, and then I'll move the pointer down once, try the match again. Oh, it works. Move it down again. Okay, and then it doesn't work. So that's where the text pointer is being pointed to after the star. From there, we try bubble down. Does the B match? Not at all. We're at a C, it says B. We say false, so we decrement back by 1. Try again. Does it work? Oops. Does it work? Yeah, it works. Okay, let's move this down. And then let's try that again. Let's keep going. Does it match? No. So this is where it changes a little bit. Instead of shift, I have to report back. I have to report false to you. And then I have to report false back to you. Now I'm hoping that by the way I write the loop should know to send it back 1, 2. Because we already tried putting the text pointer here, right? In the very, very first case, we matched all the B's to the star. We tried the text pointer here. Then we said, oh, that didn't work, so let's put it back to here. And when that failed, we should remember to put it back to here. And this is the last sort of opportunity, and that's what the red dot tells us. This is the last place we can try to put the text pointer before we kind of have to report false. Anyway, put the text pointer here. We bubble back down. Does it match? Yeah, matches. Move it down. Try again. Does it match? No. Doesn't match. Yes, it matches. Move it down. And then, of course, the C matches as well. God damn. C matches. Pointer moves down. And then sub is empty. So return true, return true, return true, return true, return true, return true. Don't care about the OR. Return true. And that would be kind of how that works. See, that's so you can see, like, again, small enough regexes doesn't really matter, but we're really having to go through a lot of possibilities, you know, go back, try, shift it back once, try again, shift it back once. Like, I can't tell if there's a lot of redundancy happening or not, but for these kind of cases, especially as regexes got more complex, I feel like this is the most structured and sort of surefire way of making things work, even if it is a bit slow. Okay. Then we have to do grouping, and honestly, we can probably do like 2 examples of grouping, and then maybe try to get started. So, if the regex looks like, by the way I've written the code, even if there's just one thing in the brackets, even that would cause a grouping effect to happen. So text might be like, let's say it fails, ABD. So I'll show you what it looks like in the tree. Basically, you have, obviously you have something like this. I said ABD for the text, but let's say we have, ABC, but then the A is wrapped in brackets. Maybe I'll show how it looks. I think we've kind of already seen this already. This is, relatively, it's a small regex, so you expect a small tree. With brackets, though, you get a little bit more complexity. You can see there's a bit more nesting going on compared to the first way. The reason is because when doing parsing, of course, you have your expression node, which has 2 kids, the OR, and also, which is empty, and also the sub. Now, because the sub, first of all, its right child will be another sub, as we've seen, but its left child normally is just a letter. Because it's grouped, it will actually this time point to an expression. This is where I believe this is where the void data thing comes in. So I'm abstracting away a little bit. I'm simplifying. I'm not using all these intermediate structs as much, but block type is basically telling me whether it's pointing directly to a letter or if it's pointing to an expression, a grouped expression. In this case, the expression is quite simple. It'll have an OR on this side, which is empty, and it'll have a sub on this side, and that sub will point to an A, and then the next sub it has will just be empty. And this is how my tree represents a bracketed A, right? Semantically speaking, like in terms of the rules, it's exactly identical to ABC without any brackets. And the tree of ABC is much smaller, right? Much less to process. But the reason why my tree does this is because in general, if you're going to have brackets, chances are you're going to have some pretty nifty things going on, right? Or whatever, I don't know. You're going to have some stuff happening. And if this is the kind of thing you have in your brackets, you want to be able to process all of this and match all of this as if it's its own entity. So it's nice to have kind of a cutoff expression node to kind of start that grouped thing. Also, more generally speaking, another way of saying it is just by the grammar that I wrote up. Wait, where's my grammar? Is it this one? Oh, this one, yeah. By the grammar I wrote up, it demands that a block is either a single char or it's an expression in brackets. So whatever floats your boat. Yeah, so this looks like that. Then you have, so this expression refers to the bracketed A. Then you have B on this side, followed by another sub, which has C, followed by the final sub, which is empty. Okay, so this is what we have, and my text is ABD. And so yeah, I've just made it like this so that it will fail, return false. But yeah, anyway, start with the expression. And then yeah, so we go through the left child, and we try to match the sub. In this case, we would actually call expression, like match expression, like whatever function we used to call match expression, we'd call it again on this node now, and try with the same pointer, but try it all again. And we would, you know, bubble down to here and say, do you match? And the A would say, yeah, I match. And then we would go to here and it would say empty. And that's cool. And then we would say, hey, this says true, which is great. And then we don't care about all because it says true. Bubbles back and say, yeah, true. But it also needs to shift the pointer down, because normally when so far when an expression node says true, it's only been this node up here, so we're done. But in this case, this expression node is not the finish line. We're just getting started, so I have to shift the pointer down as well, which is a little bit different. And in fact, I have problems with this actually. What if, I'm just thinking about like the OR case, what if, for example, this is me going a bit off the rails, but let's say it's A let's say the regex is A or AB, and the A works, so the text is like A, B, and this is like C, and the text is C. Okay. This is like me like thinking just like off the bat, so my mind's not fully clear, but I think what I'm thinking right now is what I've just laid out isn't gonna work exactly, because if you have A, like if when we run through the tree, it will see that this A matches with this A, and it will say fantastic, and it will bubble out and say, yeah, let's move on. We don't care about this anymore because it matched. Then we will be looking at C as the next thing in the tree, and the text pointer will be pointing to B and say, oh, it didn't match. So that's it failed. But we still need to give the OR expression a chance. So I think instead of, when we get to here and we say, oh, empty, instead of bubbling back up, I think we actually have to kind of reroute back to here. An empty sub needs to not be empty, but actually repoint back to here. And the only time where an empty stub is truly empty is if it's the empty sub for the original expression, because there's nothing, if the empty sub is empty, there's nothing for it to go to. But here, once you're done, if you're happy with this matches and you're here, you need to keep with this sort of root in mind, with using this particular sub in mind, you have to keep trying the match, and then A passes, A's matches, and then C doesn't match. It should be easier because this will be, you got to imagine this is a bunch of function calls, so it's like it's a call stack. So when this fails, again, I'm not thinking about this example anymore. I'm thinking about this one now. Maybe I should have stayed in my lane and done a different example, but just to get some thoughts out. When this fails because, you know, the C doesn't match the B, it should be able to report back and say, hey, I couldn't do it. And so he can report back and say, hey, I couldn't do it. He reports back saying, I couldn't do it. And so then we try the OR. Interesting. So when I have expression nodes that aren't the topmost expression node, whenever I have like an empty sub, I think I need to actually rewire it to go to the parent's right child. So what I mean by that is I'm calling this my parent sub, where this sub is the parent of this expression. So when this guy says I'm empty, instead of backtracking immediately, which would happen in this case, if there's a parent sub, then you need to actually keep going, looking at the right child of the parent sub. This is the right child of the parent sub. Okay, I'm going to change the example because I've clearly gone down a bit of a rabbit hole. I'm sort of almost jumping ahead a little bit, but I think it was important because I didn't recognize that at first. A or AB in brackets followed by a C, and the text is ABC. Right? So, okay, let me simulate this entirely because I feel like I got lucky that I caught that. I don't think I would have like I could have done that whole thing. I could have coded this whole thing without realizing it. Oops. I don't know if I would have figured that bug out, to be honest. Anyway. Okay, so yeah. We have a bit of working on the side, but we'll get rid of it now. It's recorded, but... Okay, so instead of all being empty... This is a bit ugly. I'll do this all again. Okay, that's good enough. So we have sub A, and then sub, which is empty. So that's the A by itself. Or the OR expression is another expression, which in turn will have an OR which is empty. Maybe I don't care about that one so much, but it will also have a sub, which is A, and another sub, which is B, and another sub, which is empty. Okay, here we go. I will write this again to be smaller and neater, the red part, the red writing. So right child of the parent sub. So this is the right child of the parent sub. And this is the parent sub that I've drawn up. Okay. So the parent sub of this expression is like null or something, like it doesn't exist. There's no parent. But the parent sub of this expression will be this guy. And the parent sub of this sorry, I said that wrong. The parent sub of this expression will be this guy, and the parent sub of this expression will also be this guy. Parent sub, specifically at the sub, because I'm always looking for this right child. No. 6 p.m. Okay. Can I close the door, or can I close my door? So yeah, the parent sub of this guy is this sub. The parent sub of this expression is this sub. Okay. So I have to pass that in as like a method or as an argument. Okay, so to simulate, we say expression doesn't match the ABC. We go through here, we look at the left child, and we see another expression. Okay, so we have to call, but we bear in mind that this is the parent sub of this expression. The sub here says, hey, I match the A, don't I? So let's move the pointer down. And then this guy, we go back, we go through here, and we say, hey, I'm empty. So I've got no more information to tell you. So, but instead of, saying it's all good or it's all bad, I'm going to link myself. What I'm going to call is matching the sub-expression for this sub-expression, the right child of the parent sub. So we're going to link across to here. And then this guy's going to say, hang on a minute. Oh, wait, this should say C. Oh, I've changed my tree. This should say C, sorry. And this should just be empty. Okay, so yeah, A matches, this is empty. Link to the right child of the parent sub and say, does this match? No. This says C, this says B, doesn't match. So we report false back through here, report false, and therefore, no, yes, this guy sees false on the left side, so now it's time to try the right side, or this expression. When we try to match this expression, we again note that this is the parent sub. We go through here, and the pointer should return to A. I think that's another thing. When a node experiences like a false response, it needs to have a particular behavior, resetting the text pointer or something like that. So in this case, the text pointer should be reverted all the way back to position 0. But I assume that's not always the case, so I have to think about that. Anyway, so yeah, the left child failed, so we try the OR expression, match the A, doesn't match, yes it does. So through here, it matched. So move the pointer down. Keep going. Go through here, oh, come on. Go through here. The B matches. So we move down. Keep going. We see empty. Once again, we have to link to the right child of the parent sub. So we call this guy and we ask, do you match? Yeah, I match. Move the pointer down. Go through here. It's empty. This is at the null terminator. Is there, more string to check? No, because now for this guy, your parent sub, well, this might be a bit confusing, but parent subs are parents of expression specifically. That's what I'm saying. So parent sub would have to be up here, linking down to here. There is no parent sub, is my point. So there's nothing more to link to. So the way this would fail is if there's more text to match, and there's no, and this is empty. But in this case, we're at the null terminator, so we report true, and so it would backtrack that way. So the reporting true would go back this way. Back through here, report true. So it was false on this side and true on this side, so report true. And so report true. And yeah, report true. Oh, I feel like we're barely hitting the tip of the iceberg, to be honest. I could do examples all day. Been doing it for about half an hour or something. These are good though. Caught something good. Caught something important. I didn't have this idea at all. Right child of the parent sub. Then 6. I want to try one where there's like a star, maybe inside a bracket or outside the bracket. Maybe outside the bracket. With a bit of backtracking. So like regex, you have A, B, whole thing star, another A, B, and then a C. And then the text here we go. Text is AB, ABC. So AB star should match to one of these, and this AB should match to this guy, and then C should match to this guy. So what I'm thinking is, what I'm praying for really, is that the ideas we've come up with so far are enough to generalize to this case, where, you know, we've already kind of discussed what to do with the star. It's just that instead of one character, now it's multiple. Ooh, what if it's AB or CD? Yeah, let's do that. So it's AB or CD, and let's make the text ABCD, and then another AB. ABCD, and then another AB, and then a C. A, B, C, D, another A, B, and then a C. Alright, the tree looks as follows. You have an expression, you have a sub, a board, which is empty. You have a sub on this side. This will be an expression because it's bracketed. This will be an OR, which has another expression, which have an OR, which is empty. So we have expression, which has a sub, which has an A, then another sub, which has a B, and another sub, which is empty. AB sub or sub C sub D sub, which is empty. And what's important to note is that the ABCD, which is associated with the AB, that bracketed thing, this guy, will have a star associated with it, which I'll put in red. I'll show the program and then run the program, show what it looks like. But yeah, ABCD, and then there's another sub, which is another AB, A sub B sub C sub empty. Okay. So just to run this through here, I won't bother with the text tag. I won't bother with the text, but so it's AB CD star ABC. All right, here we go. Expression. Put the numbers in. 1, 2, 3, 4, 5. Oh wait, should be, sorry. This is 1, isn't it? 2, 3, 4, 5, and 6. And then according to this, the expression block is actually integer, is generated, because there's like things between, there's things between the sub and the thing. Notice that at generation 3, sorry, generation 4, it's a child of the repeated block, I forgot. But one of the children of the 2 of the sub expression here, one of the children is star. So that's what this star is, representing the star that's associated with the entirety of this sub expression. So that's what that star is. You have, the sub expression. So yeah, you have the expression, sub expression number 1 for the A, sub expression number 2 for the B, or sub-expression 1 for the C, sub-expression for the D, whole thing wrapped in a star. Then you have, 3, 4, 5, which is A, 4 is B, 5 is C, 6 is the empty, 6 is that guy. So this is our tree, simplified of course, still looking a bit fearsome. So if we simulate, what would happen? Let's see what happens. So we check, doesn't match. We have a star, so there's going to be like a while loop kind of thing happening. We're going to see how much we can match, just straight up. A matches, B matches. A matches, B matches. A matches, B matches. Okay. So we return true straight away. This is tricky. Last time I said, A matches, we hit the empty, we should do this, right child of parent sub rule, keep going. But for a star, we don't want to keep going, If we would apply the same rule, this guy would go straight away, would go to here, right child of the parent. But with a star, this is interesting. Before we move on, we have to actually redo this. Do we recall this? I guess we have to, right? Oh my god. If a star is given, that is, we have to repeat the match of this expression. Then we go through here, we see it matches once, and instead of moving on straight away, we have to try again. Recursively? Can I iteratively do it? Can I just say... match the expression, move the pointer along, return yeah, maybe I can have another. So the way that I pass the parent sub, I can also check. I don't have to pass that as an argument, but I can check if the parent has a star, and if it has a star, rather than maybe it's not about putting. Maybe instead of putting the pointer here, I can just maybe I can immediately report back to here true, and then go like this. So instead of the black arrows going from here to here from the empty, maybe I can just do it like this. So these guys report back and update, and the pointer gets updated. The pointer gets updated, and if it matches to true on either side, matches to true, it keeps going. And if that returns true, then happy days. This worked. If it didn't work, then we have to go through the OR and try again. And if that didn't work, then we have to report false. I'm not sure if I'm making any sense, but what if there's 3 OR? What if there's another OR? What if this is an OR? If I'm using this guy as like the junction keeper, he only cares about 1 and 2, but will he try number 3? Maybe not, right? Try. Okay, didn't work. Try. No, it would work because try this way. Didn't work. Try. Oh no, maybe it wouldn't because let's say this part matches and then it bubbles back and says, yeah, it worked. Try. If this fails, he's not going to try again. He's not going to try this branch. So I don't think I can do that. So you go through here, and then you go through here, and then yeah. So the original idea stays, I think. Go like that. And then communicate back through the way you came. If it failed, then do this. And then communicate back the way you came. And if it failed, then go through here. You know, obviously it's empty in this case, but if it wasn't, try that. Go to here, communicate back the way you came, etc. So I think, yeah, I think it does have to be the sub-empty linking too. I don't think you can get away with making this guy link to the sub expression. But yeah, in the star case, okay, so I guess I have to sub. A matches, B matches, get to C. Well, at this sub empty. And yeah, I guess you have to call U again. Sub doesn't match, right? Because it's CD at this point. So you report false. And then you go, okay, or CD returns true, and the pointer would need to be shifted to AB again. Report CD works, and then you have to call U. I don't like it. Try again. AB works. Shift it down to C. Call again. AB fails. C works. D doesn't work. So revert the pointer. And revert the pointer back to C. Say it failed on both sides. So oh, I'm getting confused. I don't like it. I don't think it needs to do more calls. I don't think it should be calling. I feel like it needs to loop. I want to use loops. That's what I was able to do before. Loops made sense before. I should be able to do it again. Surely. Expression. Sub has a star because of AB pipe CD star, and then ABC. Expression. It knows what the parent sub, and it knows that parent sub has a star. When I'm considering this node, it calls the sub over here, sees as an A, sees it to B, it matches. Maybe I can communicate the idea that when it hits the sub empty, don't, I guess I got two choices. Either you go straight away or you don't. And in this case, you shouldn't. We'll report back indicating, hey, look, we managed to do a match. Okay, let's try again. I think that's how I nip it in the bud. I try this, it fails. I try this, it succeeds. Okay, let's try again. I try this, it succeeds. Okay, let's try again. I try this, it fails. I try this, it almost works, but it fails. So just to clarify, AB succeeds, CD succeeds, AB succeeds, C fails. right? Because AB succeeds, CD succeeds, AB succeeds, C succeeds, but then D fails, so overall it's a fail. So within a loop, I should be able to show that, okay, my pointer was at index 0, then it was at index 0, 1, 2, then it was at 0, 0, 1, 2, 3, 4, was at 4, right, obviously. And then these are like all the places where the pointer was. And then it got to C, and it failed, so let's keep it at C, and let's move on. So maybe it does need a point over here. But in this particular case, where you have a C star. How interesting. Oh, I feel like this just got so complicated from out of nowhere. I thought I was doing alright, but... And then, A, B... this would fail, because A would fail on the C. So we backtrack and say, false, didn't work. And in the case where it's a star wrapped around this expression, I need to put the pointer back a match. So instead of putting the pointer here, I should backtrack it, I guess, to here, because this was one of the matches, but maybe this is one too many matches. Maybe it got greedy and tried to do too much. So let's put the pointer back here and try again. Call back to here, and then ABC would work. So there is a discrepancy in how you treat the actual call. The calling structure changes. If the expression does not have a star associated with it, a star wrapped on the outside of it, then when you find a match and reach a sub-empty, you can just go straight. In fact, you should, I think, go straight. If you report back, I just want some consistency. If you report back, what's the problem? The problem is I'm afraid it will not try other options if failure occurs. Like, if you were to go A and it matches, and that's great, and so it continues onto here, maybe it would work actually, because if I say A and I go here and I keep going and this returns false, like, then it would go to here and this would go to here, and if this returns true, then instead of, see, I thought I'd have to report back to here. I don't have to report back to here at all. I can go straight to here. I'm an expression node. I can do that too. If this guy has capability, this guy has capability of doing the same thing. So maybe reporting all the way back either way works. It's just that in this case, either A, B works, or it doesn't, so you go to C. But the loop would be associated in this particular expression, right? I don't know if my struggles are stupid or not. I don't know if I'm like working through these problems well, or if I'm just being dumb. A matches. Then you try. You report it matches. Try this. It fails because you're at a C, but it needs to be a B. So it reports back fail. Because it saw a failure, it will go to the OR statement, and then this guy will try. AB matches, fantastic. So I will go back to here. I will do this here specifically. I will not go back to you. I will do it myself. I'll go to here. It will see the C. This will report true. Which means this guy reports true. And happy days. But if we're over here, AB is matching, then AB fails. We try CD, which is matching. Yeah, I have to go back to here. I have to. Because I have to be able to be like A, B, and C, D. I have to be able to, like, every time I try a match, I have to try A, B, and C, D. So I have to start it from here every time for a star specifically. Like, every time I try to match with a star, I have to try A, B, and then C, D, and then one of them will work, and I'll bubble back to here. A, B, C, D, and maybe, maybe E, F if there's more. Maybe it's A, B, or C, D, or E, F, or G, H, and all that starred. Then I have to try all of them, and then report the result back to this guy specifically. Unfortunately, here I think I can get away with, if it's not starred, I can get away with, kind of ignoring him a little bit. Ignoring this top expression node here. If I see a match, just go for it. If it fails, okay, try the next one, go for it. In fact, even this guy won't report back here. He'll go down here, like that. But this place, you have to. I think it's a clear discrepancy. I think the best I can do is make it such that, yeah, it's expression nodes that are calling the shots, not the empty subs down here. You could do it like that, but I just think it's cleaner if we use the expression nodes. What's the time now? 10:25. Been about an hour. All right, let's get coding. We've done enough prepping. I think, this will probably crash and burn on me, but at least we have some ideas as to what could go wrong. All right. Where's the... Come on. There you go. All right. So, we're going to have, I guess, Boolean match expression, which is going to take in an expression node. We're also going to have a sub-expression sub-parent node based on what we've seen, right? This idea of needing the sub-parent node for certain cases. It will be null in the cases where, it's the very first expression. And then otherwise we will give a sub-parent. Okay. What are we going to do? We're going to begin by left result is equal to match sub expression given the expression's left child. If not left result, if the left result somehow reports false, yes, then we shall match I guess or expression. I'll just make some definitions. Bool match sub expression, which will take in a sub expression star sub. Bool match or expression, which will take in an or expression pointer, and it will take an, and it will take maybe the parent as well. Do I need that? Draw that. All right. Because like in my mind, in this kind of case where you have expression, the or needs to be able to pass to this expression, the subparent. So I think the or needs it. So let's do the bool match the or expression first. So given this one, given the subparent as well. Oh, okay. I mean, this is really just going to match an expression again, isn't it? Return match expression given the or expression's expression. Oh, actually, if it's empty, what should I do? Should I return false or what? I just realized I didn't even take in the char star text string. I forgot to do all that. And the text pointer. Oh god, int text pointer. Should I make a struct for that? Like the text information? Struct text is like char star text info over here. So get the text string, get the text len, maybe, and get the int text pointer. The semicolons, my bad. That way because I don't have to pass in 3 things at once, it's a bit annoying. 8 bytes, 4 bytes, 4 bytes, I think. So yeah, given the, wait, I think I have a way of, can I be like, type def this as text info? Can I do that? No? Is it that? Struct this is text info? I think this works. Oh, I've really made my camel case and Pascal case and everything. Sort of mixed them up together, haven't I? Text. If or expression is empty, then what? Just return what if an empty or expression is kind of like an empty you know what? This shouldn't even be called if or expression is empty. That doesn't make sense, because then there's no or to check. Like, so if not left result and not expression or expression is empty, you know, if it's not empty, then call it. And so I will assumes or expression is not empty. Gives a false result if an empty or expression is given. I don't know. I'm going to try my best not to call this function if there's no or. If it's then return false. But yeah, this should never really run. Otherwise, this is basically just a gateway to call match expression again. Given the text and given the or expressions expression node, and given the subparent, whatever that may be. Okay, now the tricky part. Actually, match expression doesn't need a has star thing? Probably not, right? In fact, I should be thinking about the star stuff already, shouldn't I, technically? Like, in the case where, like, what example was it? Was it this one? No, this one. If sub parent, that is making sure it's not null, and sub parent repeated block star is empty is not true. Boolean has star is the negation of all this. Parent. Oh no, but I have to check. I have to check if it's null first before I do that. Okay, leave it. Okay. So if the parent is existing and there is a star, then what? If the subparent has a star, then I need, assuming that the point has been moved in the right place, I have to go again. I don't want to do it. Then Boolean matched expression equals true. While matched expression, we're going to do this. We're going to match the left expression, the sub expression, and we're going to match the right expression. I'm just thinking, I'm getting worried about something else now. Like, what if I'm saying only match the right expression if the left expression fails? What if the left expression passes, but is actually the wrong match? Like, what if you have something like A or... Oh, we had an example of that, didn't we? A or AB? Ah, but no star. A or AA star B, in which case you'll have AAA well, to be fair, A versus AA star doesn't really mean anything. You might as well just use the left side all the time, right? So that doesn't really make sense. Oh, I just don't know if I'm backtracking correctly. A versus AB, and the text is A, AB. This is A, AB. AB, let's say. I don't know why I wrote it so sideways. Hang on. A, AB, AB. And then B at the end. The regex is A or AB star B. So what my program, based on what I'm thinking, what my program I think is going to do is it's going to match the A, it's going to match the A again, and then it's going to say, oh, this guy can't match the B, so let's go to the next part. This matches the B, then I'm at the empty, but there's still stuff left, which is bad. Which is bad. So, I say, okay, failed, I guess, failed from here, which means, okay, it failed, so you should sort of reset the text pointer, and so it's going to be like, oh, okay, let me just try not do so much. Let me just only have one match instead of two matches. Try again. Oh, it failed. Okay, let me try 0 matches. Oh, it failed. Okay, therefore the whole thing failed. I'm not handling the all thing correctly. This example, this is the last one. I think if I can crack it, this is the compound, a pipe, a group, and a star. Everything. This is the last. This is endgame. This is the one that is going to be the tough one. How do I ensure that my regex tries all possibilities? It makes sure to try the pipe first within the group, then it tries to do the star across all different possibilities. It tries the A, it matches. It tries the A again, it matches. What if, when I do the backtracking, what if instead of just backtracking, I first try the OR? Because, like when I was talking about before, was with a single star, right? Here, right? I was saying A and then B star, and you match all the B's, and then you try to match the next B, doesn't work because you're at a D, doesn't work, so you backtrack to a B. In the case where the star has multiple possibilities and OR, instead of backtracking, what if your first instinct is to actually try another possibility? Check the OR expression first. So if in the case of down here, it's A, those are my matches. Then we go to B, it matches. Then we have AB left after with no more regex left. So it failed. So we go back to here, and instead of backtracking, it is backtracking, but instead of just saying, okay, we'll only make the star match the first A, we say, what if, with the pointer pointing here, what if we try this guy? And it will work. But let's say for some reason it didn't work. Let's say, let's just put a C on the end just to make sure it fails all the time, right? So, you would put A, then hopefully we can get it to say AB, then it would match the A again, right? No, then it would match the whole of AB again. No, it wouldn't. No, sorry. It would prioritize the left, so it would match the A, and then it would say, okay, I can't match anymore. It would match the B, and then say, oh, the C failed. Okay, so let's back up. We matched A, AB, and A by itself. Let's try match the whole of AB. Oh, it worked. Okay, let's try. B doesn't match with C, doesn't work. Okay, so that failed. Let's back up to here. Well, he matched AB. This didn't work either. So let's go back to here. We've matched the A. We matched the A by itself. Let's try match the AA. God, my brain hurts. I think it has to be massively recursive. What if I go the other way? What if I just ignore the stars and try to match, and then, okay, I'll try one match. I'll try match it once, and if that doesn't work, okay, I'll try match it twice. I feel like just the practical use of stars, normally you're expecting a star to match more than once, so just by how they're used, I don't know, I could be wrong, but when I use a star for regex, normally it's because I expect it to be usually I usually use it for dot star, because I just want some arbitrary number of characters. So I feel like you're better off trying to do a maximum matching kind of thing. What's the time? 10:43. What's been an hour and a fifth bit? Yeah. I just don't know if I see it well enough. So when you're matching an expression, and there's a parent sub with a star. We've checked that. What are we going to do? Match left. If it worked, try match left again. As it works, try to match left again. If it fails, match right. It's kind of like a post traversal thing. So bearing that in mind, if I think about it like a tree, I'm gonna try match the left. When I'm saying left, I mean like this is my left, this is my right. Of course, there could be an arbitrary number of these before the star, but just for now, I'm thinking of there's only 2. So this is my expression. I'm gonna try match the left. If it works, I'll match the left again. If it works, I'll match the left. And let's say it fails. It fails here. So okay. I will then, having matched it, this many times, I will then traverse the rest of the string with the stuff after all this, and see if I can get a match. If it fails, okay, I match the left. Oh, I should match the right as well, actually. Sorry, I'm gonna try and match the right first. Let's say that works. And then let's say I try and match the left and the right, and they both fail. So this is the maximum number of matches I have at this point. So I will then traverse the rest of the string using the right child of the parent idea and see if I can get a match. If I fail, then this guy should back up. This guy, I shouldn't match with this guy anymore. I should back up to here, and I should just try this now, shouldn't I? Let's try these 4 and traverse out. And if it fails, then I'll go back to here. But I still have to check the right, so I'll match the right, and I'll do that whole thing again, and keep traversing. And if that all fails, then I'll just try these 3. And then I'll come back to here, go to the right, blah blah blah, try my stuff, traverse, come back. If it all fails, I'll just try these 2 matches. And then if that fails, I'll go back to you by yourself, try match your right, left, right, all these possibilities. And then go back, and then try it empty. Nothing. Empty. No matches. Just try it by yourself. Empty, no matches. Makes sense conceptually, I think, but I don't know how to code it up. The fact this is an arbitrary number of children, arbitrary number of or things, pipes in this expression. Wow. Okay. So yeah, recursion feels like it would be the most helpful, but I don't know. If we're in the case where it's grouped and it has a star, we're going to attempt to match the left. Try and match the left expression. Try and match the or expression. Boolean in reality, the expression will look like this. It will have a sub, you know, and that will have its details, and then it will have an or, which will have another expression, which will have a sub, and an or, which will have another expression, which will have a sub, and an or. Sub will have its details, and or will have, maybe say that empty at this point. Okay, so there's sub 1 or sub 2 or sub 3. That's what this is saying. So what am I, so that's three things. It's like A, B, or C, D, or E, F, and this whole thing I'm saying is mapped to some sub which has a star, right? So what am I trying to do? Try match the sub. Try match the sub. If the sub matches, then try match it again. If it fails, yeah, okay. If it fails, then go. And if we get back to here and it didn't work, then okay, I'm sort of seeing it now. I think a recursive solution will be a lot easier. No while loop, unfortunately, I think. Okay, here we go. Bearing in mind that the text pointer is stored within this struct. Bool left result is equal to match the sub expression given the text given the expression's sub. If left result for the star, then we are going to note this index, note the start, int current text pointer is equal to text pointer. That current text pointer points to the location of a match. This I think will be important for when we want to, if we want to backtrack, like remove a match. I think it will be important to note down this position. If left result, then fantastic. Left result then becomes match the sub expression of the subparent, their child, and the text. So after we've tried to do a match, oh wait, no, sorry, this is wrong. Else, this should be in the else. Oh, I've reverted a little bit. I've put my braces over there. If left result, else, try this. If left result, then we're going to recall, we're going to say match expression again, given the new text, given the exact same expression, and given the exact same subparent naturally. So yeah, hella recursion. We're going to go into a new call frame, and we're going to try redo all of this. Else, left result, using the same variable, I don't know if that's silly. Left result, we're going to take all these left matches, and we're going to try to match what's left in the text, because the text pointer should have moved, using the subparent's right child. Left result. And then if left result that indicates that we managed to actually get a full thing, I think. And we can return true, because the idea is like, I managed to, with my number of matches that I've done, I went out the tree, as in, like, did this whole thing of, from here, jump back to the right child of the parent, went there, did the remaining of the match, found a match. Otherwise, if there's not left result, then hang on. Didn't I say do the right child first? Yeah, I did. Hang on, wait. If left result, then go again. Else, bool right result is equal to match or expression, given the text, given the expressions or expression, and given the subparent. So I'm saying, if we try to match the left result, if we try to match the left guy, it didn't work. Then before we jump out, let's try matching the right result. The OR expression will take us back to another match expression, which will also see the star and also create its own block like this. And when it does that, it will try match the left, then it will try to match the right. God. If not result after you did all that, then I think we should try matching the right. Like, if you tried all this left stuff and you did all that and it didn't work, then you need to try that. You need to give the right guy a chance. Copying and pasting is bad, but oh, it's getting gross. What am I trying to do? Keep track of the current text pointer, match it, match the left guy. If the left OR works, I do need to check if the left result works, then call it, like, go again. But if going through that whole process doesn't work, then you have to try. Well, first, I think you have to first reset the. I think you first have to set this back to the current text pointer. Have to bring it all the way back, have to snap it back, and then try to pass the. Maybe there's no else. Put an else here, and return true. But if it doesn't work, don't do this here. Just reset the text pointer. and then try right result. No, match. If or if the expressions or is empty, I'm trying to figure out. It's a bit of a weird one. Yeah, let's just do this. Bool right result is equal to match the or expression given the text and the expressions or expression and the subparent. Okay. If right result matches as we wish, if we manage to actually then we have to recall, then we have to match expression again, right? Again, because of the style, text, exact same expression, holistic expression, and the subparent. Basically identical to this guy over here. Restart, like if we get a match, try to do it again. And bool result. If not result, then again, reset this guy. Because going down this path didn't work. But if we get a good result after doing all this, then we should return true. And if we still haven't returned true from here, then that means we tried going left and trying all those possibilities. We tried going right, going through all those possibilities. All that's left to do is try not doing any more matches. And just match sub-expression given the text and given the subparent's sub-expression. And I think we just return this as the final last-ditch effort. I have no idea if this makes any sense, but this is what I've come up with. And this is just for this case. Although I think the other cases are easier. Okay. Get rid of all this. Don't know what any of that was. If we're in the case where you have if it's a bracketed expression with a star, then int current text pointer equals text pointer. Boolean left result equals match sub expression given the text and the expression sub, because what are we doing? We are figuring out if we are able to match the sub expression to the current text where the text pointer is. If that works, then we've managed to do that. We should try it again. We should try matching another instance of this star expression. So we will call match expression again, given the text, which should be updated with the new text pointer, the same expression that we just are in, and the subparent. And if the result of doing that is false, then we're going to reset the text pointer. Otherwise, happy days, we return true. Boolean right result equals match or expression. So after we do this, if we haven't returned true, that means that, trying to match the left, right, the left of the or, trying to match the left of it didn't work. So let's try the right of it. the right result is match or expression given the text expression or expressions. So let me just think about something, right? If I have three, I'm worried if I have three or things, this is not going to work out the way I think it is. Like if I have A, B, or C, D, or D, E, A, B, or C, D, or E, F, sorry, it's all starred, and then I try the left, A, B, and then I try the right, which is C, D, or E, F, from the perspective of the top expression. What would happen? Let me draw this out. I have my expression on top, which, has the sub, which has like, I'm just going to write it as AB for now. And then I have my OR, and which leads to another expression, which is my CD, which has my OR, and then another expression, which is my EF, right? And the idea is I have A, B, or C, D, or E, F star as like my regex kind of thing, and some other stuff as well, but this is the part I'm caring about right now. I have a text pointer pointing to some text. I try the left, it works. I recall expression. I try the left again, it works. So like, let's say the text is like A, B, A, B, A, B. I go across to here, and then, after three ABs, there's a EF straight away. AB, AB, AB. So after the first three ABs, it won't work anymore. So what's going to happen? If left result, which eventually will be false because it won't match, so we'll try right result, we'll match the right result. So I will match the OR expression to with the text pointer pointing over here now. So it will try CD. Okay, maybe it does work because it's going to try CD. It won't work. But the idea is, like, from this guy's perspective, all that code of checking left and right is going to happen through to this guy. So he will try left, and that will work or won't work, and then he'll try right, which is this guy. And then we'll get down to here, we'll try his left. Okay, maybe it'll be okay. Maybe it'll be okay. If right result, you try the right. I'm just a bit confused because I feel like if this is the case, then when the EF gets matched, it gets matched in the call stack, in the what's called stack frame, where this guy is the expression, not this guy. This guy was where it started, AB, then call it again AB, and then call it again AB. Then AB doesn't work, so let's call right. Now this guy calls, let's try CD, doesn't work, so he calls right. Like, to annotate my code, annotate the image a bit more. Testing this is by calling match the sub expression. And then when that eventually fails, it's going to try match the OR expression. And so that's going to call this is going to call here because OR expression calls match expression, right? So, and then this guy in turn will try the match sub expression over here. And when that fails, it's going to call match the OR expression, which will sort of pass control over to this expression. And this guy will call match sub expression. Okay, so match sub expression will eventually, so this guy over here will eventually travel to EF. That'll match and then it will try left, and then it will fail, so it will try right, and there's nothing there. And so it will then do the thing, right? It will then do the, traverse the rest of the tree with the remainder of the string. I'm saying like if there was more letters in the text. So after it matches the EF, it will go over here. It will try to match the GH just by itself without any help from there. Yeah, this does make sense, doesn't it? No, it doesn't. Wait. wait. Okay, wait. I just had a thought, so that's why I kind of stopped myself. What if there was EF and then there was another AB? What I wanted my thing to do was match that AB over here. But if I'm down here, how is it going to see that? I think this was my fear. I think this was my issue with it. It was like, if an old string, like AB, shows up, I'm not sure if it will match that AB. AB will match 1, 2, 3, then fail, it will go OR, CD will fail, then EF will see that EF, will move the pointer down to AB again. And then what? It won't match the EF. It won't match on this side because there's nothing left. So I guess, yeah, it will try this strategy of like going out, and let's say that fails because there's nothing left in the regex. Wait, what if, okay, instead of matching this expression, the exact expression I'm in, I have to match the subparent expression, which initially means the same thing, but that's not always the case. I have access to the top node via the subparent. So when this matches EF, I have to call this guy again. I think this is it. I think I cracked it. When you hit EF and there's nothing more to match, when you hit EF, you're gonna call it match expression from up here via the subparent, and then you'll find the AB and you'll do all the matchings you could possibly do. And then when there's no more matches to do, it will travel down this tree. When there's no more matches to do, that's when it calls match sub-expression on the remaining text, on the subparent's sub-expression, the right child. It'll try its best. I don't think I can return though. Or can I? Oh man, I'm confused. This will try. Once it returns, if it says false, what do I have to do? I have to backtrack to here and say, okay, we tried the right child, can you now? I think maybe I can return. Because my thinking is, okay, let's say we're down here, and because what's going to happen is we come back to here, we get AB, we get AB, then, can't match the AB, can't match the CD, can match the EF, okay, can match the EF, so then call this again. AB is there, okay. And, okay, I'm going to add a bit more to the text string. Let's say there's a X or something on the end, right? So AB, 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 EF, AB, and then X. So AB won't match, CD won't match, EF won't match, and there's nothing here. So we're gonna go to the string. Does it work? Obviously not, because there's nothing left in the regex, so it kind of should return false. And that's what this is. This will return false. So this guy, we'll go back to this guy and say, I got false. No. This guy would talk back to this guy, right? No, wait, I'm stupid, sorry. This guy, who was called by this guy, would say, I got false. And it was AB, then we tried matching again, A, B, C, D, E, F, nothing, call it false, false, he says false, which means you are false, which means this last match maybe was a bad idea. We'll say E1, E2, E3 for the three sort of expression nodes. Matches AB, AB, AB. Can't match AB again, so it calls right. Can't match the CD, so it calls right again. Matches the EF, and therefore calls E1 again. This is like, so that this kind of, because it matched, it will go back to E1, calls AB, so it will kind of redo itself, call back to itself, and then it will fail, so calls right, it will fail, so calls right, this will fail, so we'll call the right subchild thing that we've been talking about. This will respond with false, because no way would it work. So then this guy will respond with false, respond with false, respond with false, respond with false back. So this match, as good as it might have seemed, might have been wrong. The left match. So I need to call the right match now. Is that what's happening? So when it gets back to here, the left result returned true for this guy. But when I try to match expression again, all this would have happened returned false. So I need to try the right, and that's not going to work because there's not going to be any matches. So then, assuming the text pointer isn't messed up or anything, I just call match subexpression for the same text pointer. For an unmodified text pointer, I'm going to call, which means instead of taking this match, which was the AB match, I'm going to just go for it. And it will return false again because the regex isn't going to work because it's an X. So return false. It'll return false to here. So this guy will say, okay, I matched. So let me, instead of matching, let me try call my OR. Again, I think I should check if it's empty or not. In this case, it's empty. Let me try call my OR. That will return false or something. So okay, then let me try instead of using this match for the EF, let me just only match up to here, put the text pointer here, and yeah. So when I feel like this is gonna work. I don't know. Okay, I'm gonna back it. I feel like it kind of makes sense. Else if there's a subparent but no star, then what did I say? If there's a subparent, then match the sub expression. The sub expression doesn't really take in the parent, does it? Wait, yeah. Match the sub expression. Given the text and given the expression's sub. So we're going to match that. What if there's like a star within then the sub expression's responsibility, not the value, not the expression. Int result equals this. Can I just return that straight away or what? Int result equals match the sub expression. I think so. Int result equals match the sub expression. If so, that's the left child, isn't it? If not result and this expression or expression is empty, is not the case. If it's not empty, then result, I said int, should be boolean. Result equals match or expression given the text and the or expression and the sub parent. Return result, I think. If result, this is like the short circuiting, if result, then return result. Otherwise, if there's an OR available, then set the result to that guy, and then return result. Hopefully that's correct. I'm kind of brainless now, but that's alright. I feel like the sub expression needs to take in the sub parent. Just in case. In the sense that, like, if there is a sub parent, then maybe I will take the idea of like just making, yeah, from an empty sub-expression going over here. I don't know. Else if you're a subparent, and then, I don't know, else, if you're just the straight up expression, will it be the same thing? Try the left sub-expression, try the, if that works then great, otherwise try the right sub-expression. Yeah, I think, honestly, I think it's going to say else. Goodbye. And then return, like, false in here. I mean, oh no, it's if else, so there's definitely a return statement in all control branches, whatever. Alright. Then we have this guy. Okay, so if sub parent, so kind of the same thing. If it's this case, I feel like it's different. If subparent and there is a star, then what? Do one thing, otherwise do another? No, but these kind of things only really matter if you're empty. If sub is empty, right? And then you ask if the subparent and subparent repeated block star is empty is not the case. That is, there is a star. So if we're in the really scary case, then that means that we need to communicate back to the guy. Maybe it's not about if it's empty or not, maybe just in general. Return true or something. Oh, I'm confused again. Wait, so if I'm thinking about like this case again. So expression, we have sub, which has an A in it technically, and then another sub which will have the B in it, and then another sub which will be empty. So expression A, in the very first case, we should see that, you know, there's a character there which is an A, and that's cool, and it matches the text pointer. And then there's a B which matches the B, and that's cool, we should move the text pointer. How do I actually do that? AB's over here. Yeah, if we get to A and then B and then we get to the empty, then I think we can just return true. We say, yeah, it matched. Happy days. Else, if there is a subparent, but there's no star, then we need to do this thing. We need to match the sub expression again, text given the sub expression oh my goodness. I need to know the parent of the subparent or something. Oh my goodness. Don't I? Because how am I meant to act? Oh. Because when I call this, I think the pass is gonna have to be updated. Oh no. Pass the sub. I said subparent sub expression. No. Like I was gonna be like, oh, it's null, but it's not necessarily null because if I have nested expression, like nested brackets, if I have like A, B, or C star D or something, then like I have the overall expression, and then I have like this expression, and then I have this expression. So like the parent of this subnode comes from this expression, who also has a parent subnode, you know? Dear. Okay, well that's unfortunate. Can I get around that at all, or else if subparent? Match the sub expression. Match the. I don't even know what's happening. I've kind of forgotten what I was just doing. I just sat still for a minute. Bulls. Match the sub expression. Text info, text, sub expression, sub expression, sub parent. Batch expression. So it's originally going to be null, and then when you are in a sub expression and you're about to right, because when you the idea was if you have a left child, you're going to check if the left child is an expression, and then you can pass yourself as the parent. Okay, yeah, it's not a bad plan to be fair. But now, yeah, if you're going to use sub expressions to go back up the tree, then there might be some problems. I mean, I think a stack would work, but I'm not sure. Like, if I have a stack, a global-ish stack of subarray somethings, parents, subparents, not subarray, sub-expression parents, then maybe I could do some popping and pouching, but I feel like it's easier if I just change the tree structure. I think that'd be the more clever thing to do. I feel like a stack would be a bit unwieldy. Okay, let's just pretend that there's not going to be any nested braces, and therefore this is inaccurate. Subparent not necessarily null if grouping is nested. If you only have one set of parentheses, like how we've been testing so far, like there's only going to be one kind of subparent, because you're going to have the original expression, and then you're going to have, sub 1, and then you're going to have the OR. This is one block, and so the OR will be empty on this side, and then you would have you'd have your sub, and then its child would be a bracketed expression, and so it would be an expression node, and then that's how this tree comes out. But and so yeah, this is the parent, and then this is the child or whatever, and you do your thing. And therefore, jumping out, you know that the right child of the sub or whatever is going to not have any parents or whatever. Alright, I'll see if I can adjust the parser a bit to like so that every sub expression and maybe every expression node has a link to the parent sub expression or something. We'll see if that's helpful. For now, we'll just keep it as null. If it's a parent, can I just return this? If there's no star, then you don't have to do any of this backtracking stuff. Match the sub expression outside the loop after you've gotten to the empty, you've matched all that stuff. And you're going to yeah, surely you just return it, right? Like you just return this result for the remaining thing. Hopefully. And what's the else? What's the else case? There's no subparent? Yeah. If there's no subparent, then yeah, I think you can return true. Oh. Return whether the text pointer is greater than or equal to the text line. If you're at an empty, remember that our goal is to make sure that the entirety of each string matches the entirety of the string. The entirety of the regex matches the entirety of the text string. So you want to make sure that you've matched the entire text. I've said this wrong. Text pointer. The text pointer needs to be past the text line. You have to have matched everything in the text line. Otherwise, problems. Okay. Else, if it's not empty, then we have to check if like this guy has a star. I have to check if the child of you is an expression or like a bracketed expression or just a regular character. Oh my god. If sub repeated block type equals BT single child type. If it's single child type, and there's no star, like what? If there's no star, then literally all we're doing is checking if text the string indexed at the text pointer is equal to, well, first of all, we have to make sure the text pointer is valid. If the text pointer is greater than or equal to text at the text len, then return false, because basically we've ran out of text but we still have stuff to match. Otherwise, if this is equal to the character, oh, for God's sake, single char or something. Pointer, sorry. Oh, escape. Ugh, okay, we'll just take this one out. Need to handle escape chars. Wow. If this is the case, so gross. This is how I access, in drawings I've just been saying A, B, whatever, right? But this is how I actually have to access the char. If text string text pointer is equal to that guy, then happy days. Or okay, I should make a variable char data is equal to this guy. If char data is a dot, or the text at the pointer is equal to char data. What's wrong with that? Oh, semicolon. Then simply move text pointer, move that on, and match sub expression given the text, given the sub child, the right child, and the same parent. Do I have to return or what? Else if sub repeated block type equals bt single, and there is a star. I should have said like has star is empty. This is like a terrible field name. I could probably change it actually, but anyway. Make note of it. Change is empty for star to has star. Just because I feel like is empty, like having to negate all the time is really annoying. BT single char type, and it is not empty. Then we have to basically do. Maybe we can try a similar strategy. I feel like you should be able to do this like iteratively, but for the sake of trying to keep the pattern the same, if let's get the char data again, and then if it matches, it's a different strategy. If the char data is this, or it matches, move the text pointer along, and we're going to say boolean match again. So we're going to call on the same sub. This is the difference. Before we called it on the child straight away, here we're going again. We're going to match again on the sub because it's a star. If it matches, go again. And it's going to do all this stuff. Same sub, so it's the exact same situation. It's going to be a BT single char type with a star. We're going to call match sub expression, and eventually it won't match. It will hit this else case. it won't match. No, do not increase this. Else, text pointer wait, no, it should increase. Sorry, I'm stupid. If it doesn't match, then don't increase the text pointer. That's what I was thinking. Don't increase it. Match sub expression given the text with no change in the text pointer, given the next sub expression thing, and given the sub parent. That's what it was. You know what I'm saying? And then the idea is I need backtracking. So I should probably just like I did in this expression function, I should probably say int current text pointer, just to save the state, is text pointer. You silly goose. Okay. Can I say if match again? Then return true. Can I do that? Like, oops. Bool match again. You try to match with the same sub with the moved on position. And then maybe I don't need an else. I'm praying that basically if I set text pointer to equal the current text pointer, basically resetting where it was, essentially meaning that I don't do this particular match. If there was a match, move the text pointer along, match the sub-expression, and if after I match the sub-expression it worked, like it just returned true, that to me indicates that yeah, I tried to match again and I managed to figure out something, then return true. And then if you haven't returned yet, then it didn't work. Either this never matched, or this guy didn't return true. In which case, either case, it'd be good for the text pointer to point to where it was originally pointing to, and then match the sub-expression for the next sub-expression. Not this one, the next one, given the sub-parent, given the text. I think I can just return that. So that's if it's this. Now, if it's now this is what I'm dreading. Else if it's a BT expression type, and we'll say, yeah, it is empty. Right? Hang on, did I say the same thing twice? And not it's empty. Oh, right, sorry, yeah. Okay. And it is empty, there's no star. Then, you are the parent. You are the parent, so expression pointer is equal to expression pointer okay, So we got the expression. I need to match the expression given the text, given the expression, given the parent, which is you. Can I just return you straight away? There's no star involved, so... I mean, you might have a star, but above you there's no star, so... So... Are we cool? If I just call match expression on text, then, you know, the evaluation match expression, and then that expression tries to match as much as it can, and, you know, maybe it has a star that it has to deal with, but it will do it and then continue on its way. It'll continue on its way. It'll even travel back up through the tree to keep going once it reaches its empty sub expressions and stuff. So, you know, can we just nice me and can this work, please? Else if, and then the scary one. It's not empty, so there is a star, and it's an expression type. I don't even know what that means. So like, it's kind of like this situation where it's like, the parent has a star. Oh no, so you have a star. Wait, but doesn't the expression handle this? So... Wait. Do I get away with it? My thinking is like, either the sub is, you know, just a single character, no star, no nothing, or it's a star, or it's like bracket A, B, C, D, or it's bracket A, B, C, D star. These are the 4 cases. But in the cases we've kind of done these 3, I think, right? If it's single char type and there's no star, single char type there is a star, expression type there's no star. If you get to here, this part of the tree, and you're at some point in the text, then you want to try match. Yeah. I believe in both cases you do this. So honestly, I think because you're passing yourself as the parent, the star information gets traveled along. I think both cases wrap into one. I lost the brace. And then I didn't have an else, so I'll just say return false if that doesn't work, but yeah. Is there any chance that this is like remotely correct? Like, what did I just do? It's midnight almost. I have to go to sleep soon. Subparent, if there is a subparent, and there is a star. This is so dumb. And there is a star. Then the current text pointer is equal to text pointer. Keep track of where the text pointer was pointing to. Left result, match the sub expression. Did it work? Oh my gosh, if it did, then let's try and match the expression again. Wait, what? I'm reading this out again. It doesn't make sense to me. It's like 10 minutes. It was like I did this like half an hour ago or something. Left result. If left result, then match expression. Ah, yes. Sorry, I forgot why I did this. Yes. You want to go back to the subparent sub expression. That's the start of this thing, which initially would be the same thing as expression, but if we go down the tree, then eventually that won't be the case anymore. We want to go back to the start, yes. Match the subexpression, try again. If we try that and it didn't work, then reset this. Otherwise, oh my gosh, it worked, return true. Boolean right result. Match OR expression. Text, expression, or match the OR expression. So I think I need to, okay, I'll look into this a bit more, but if the right result, then if we manage to get a right result, then exact same line as up here. Try again. If no result, then reset, otherwise return true. And if we haven't returned yet, that means that going left and right didn't work. So let's just try not do this match. We've resetted the text pointer. Let's not use the star here. Let's move on, same text, but let's move on to the subparent's right child. Ooh, wait. This is the other problem. Is it? This shouldn't say subparent anymore, should it? This should, like, this is kind of like the null case again. Like, it should be up a generation. If I go back to one of my examples. When I do all this, like, this is the subparent, this is the original, this is the overlord expression. This is sub expression, this is the expression from a bracket. So this is the parent. When I do all this and I eventually bubble back up to here because I hit the empty or whatever, or I hit an expression that and I want to try, without using the match, and I want to go up to here again. This parent, the parent is not this guy. Like, obviously it's the parent, but it's not in this context. When I say subparent, I mean the parent of an expression. So it needs to be the parent of this guy, which in this case is null. But again, it shouldn't be null. Like, I shouldn't say null here. I should actually be able to detect, I guess, where the next subparent is or something. You know what I mean? Like, I should be able to figure that out, but I can't right now. I don't think the code has the capability. Yeah, and then Boolean result, this one, bing bong, and then whatever. Okay, so let's just YOLO it. I need to create, so strlen, so I have the text length already. I should have access to the text string, and text pointer is just 0. So struct, no, I don't have to say, I can do text info, can't I? Text is equal to, if I do this on the stack, nothing bad happens, right? Text string is equal to, argv at text string. Text len is equal to text len, and text pointer is equal to 0. Ta-da! Did it work? Is that fine? I think I prefer it without spaces, to be honest. I don't know. Can't tell. Anyway, I've got the text, and now I have to say match expression given the text, given the tree. That's what I called the expression thing. It has to be address, the address, because I said pointer. What else? And the subparent is null. This is the only place where it should say null. Everywhere else it shouldn't say null. Shouldn't say null. Should be precise about what this. Remember that subparent means the parent of an expression node specifically. Alright, yeah, so results is equal to this. If results printf complete match, else, wait, I have ternary operator. Results, then, in fact, I don't even need the result. then printf match found, otherwise printf match found. Okay. Oh, of course. Whoops. Incompatible, passing this one into this one to 25. Wow, so early on. Oh, whoops. Yeah, this should say match sub expression, right? Wait, now I'm confused. Wait. What do I want? Oh no, there. This is just supposed to say oh no, because wait a minute. Wait. Yeah, no. So this is me saying I found a match from left result, and so I need to redo the match on the top expression. But that top expression okay. This might be really ugly, but original expression is equal to subparent sub expression no, not sub expression. It is wrong. It should be repeated block data, and it should be cast to an expression pointer, I think. Yeah. Conceptually, it's the child of the subparent, but that what I had didn't even make sense because this is the right child, not the left child. It's worse when it works because then I know like something dumb's gonna happen. Okay, we have a few examples we can try. Let's start nice and simple. AB. Oh, well done. Good job, mate. You didn't mess up the easy example. Alright, let's try AB, CD. Wait, can I just check something? When you match an expression, if parent and it's not empty, what if? Okay, you do try the left child. Okay. Whoops. Like you try both children left and right like that. That should be fine. So this is so A dot out, AB, CD, and what CD you're saying? Okay, we'll try AB first. Okay, very good. Well done. What CD? Oh, well done. Can I try something? Wait. Let me be like printf. Wait. result equals. How do you print booleans? It's probably okay. I guess printing booleans wasn't really a C priority. Right child. If these print statements work the way I think they will, then you should say 0, 1. I'll try compile. Yes, I forgot \n, but yes. Oh. What? Oh, yeah, because strictly speaking, if you think about the tree structure, I didn't think about that, but basically it goes, it's, sub, you got the expression, sub, and then expression again, sub. I don't know why I'm using circles, but I think this is empty at this point. This expression has sub or expression, and that it's because of that, because of these two squares, that's why it prints twice, because you have this is your A, this is your B, and then your empty. Just color it in for empty. Or, and then you have another or, which is empty. And you have your C and your D, and then empty. So what's happening is you start here, and you can sort of confirm that with the thing, I hope. So this runs when you don't have any subparent, right? Oh no, sorry, when you don't have a subparent, this specific case, subparent, and in the case where there's no starred subparent, that's what I meant to say. Okay, so what happens is it goes bing, bing, bing. You call match evaluation or whatever here, expression I mean. I keep getting expression and evaluation confused. Match expression here, you call it. You try A, and so when you do that, it prints, you get false, then you go here, and then you get true once, this will get true back, and this is the left child of this guy, so it prints false and then true for both left and left. And then right child from here gets 1 because this guy communicates 1 back. And then this guy, they all have it. So this guy gets a 1 back because of this dude, comes back here to, and then you say left child as well. The tree is being traversed somewhat accurately. Okay. Let me get rid of these print statements because they're going to get annoying. Especially because of that recursive nature, things repeat. There's so much redundancy, like... Okay. All right. Let's be kind to ourselves. Let's say so let's compile, and then let's go a.out, and then let's say A B star D, and then A B B B B B B B B D. So no backtracking, nice and simple. Okay, well done. Let's say we have like 1 B. Okay, well done. Let's say we have no B's. Well done. Okay, good job. Now, the scary thing. What if I have some B's, and then I have a few more B's? Oh, very good. Because even though... Wait, why did I put all those B's? I didn't meant to do that. Well done. Because even though the B star doesn't need to match to anything, the 2 B's over here and here need to match to something. And they don't, so no match. Very good. Now, let's say we have this. This is where backtracking comes in, because the B stars, the way I've written it, I think will consume this, and failure will happen, and then, you'll eventually have to backtrack and... Oh, good job, well done. You actually didn't mess it up.
congrats. If I put some more bees, should be fine. Cool. Again, it has to do a bit of backtracking because the bee star will consume all the bees, I believe, and then realize, oh, something didn't work. I have to backtrack a little bit. Okay. There's definitely bugs. I don't know where they are, but they're definitely somewhere. I kind of tried this already. Oh, not really. This was a weird one, right? Because of the weird... Okay. A or AB. I need to put quotes as well. Without quotes, it gets confused because pipes and brackets are like important or something. And then ABC. So just to clarify, this matches because you have the AB and then the C. Ah, there it is. Yeah, I knew it was going too well. Alright, we'll oh, I don't know, do I want to stop? I don't really want to stop. Okay, what is this case? It's an expression. No stars. It would have entered an expression. It would have tried to match the A and then tried to match the C. It wouldn't have worked. So I would have thought match the sub-expression. Match the OR expression. Match the sub-expression A. I think there needs to be another case if there is a subparent, because right now I think what's happening is if subparent and there is a star, right? That's one case. And then you said else, so this case is falling under there. But what's happening is you're matching the sub-expression A, because match sub-expression, expression sub would be this guy, which in turn would have to match, which would see that the child is an expression and call that. Match left, match right, match left. Match the left sub-expression, which is a single character. It matches it, sees the sub, sees the empty sub afterwards, and then tries to go BC with just a C? Very tricky. Printf, what? Printf, left child. Wait, was this the last changes I made? Yeah, okay. So, let's just see if this is helpful. We'll see. No match found. Not really. Left child result. I can try to draw the tree out real quick. Looks like this. Wow, that's a bit messy. Okay, let's try again. So we have A or AB followed by C. You have the expression. You have the sub. You have the OR. You have the expression. Nope, there is no OR, sorry. That's within the bracket, so that will happen afterwards. This sub has... Firstly, it has like an expression thing in it. This is the C. This is empty. This expression has a sub and an OR. This is where the OR is. So this OR has an expression which has a sub. This sub has an A in it and then is empty. This sub has an A in it, then a sub which has a B in it, and then a sub which is empty. And then this has an OR which is empty. Okay, this is this tree, relatively extensive. And the text was ABC, right? Yeah. So what's meant to happen is you match the expression, you match the sub, you match the expression again, you match the sub, you see the A, you go, yeah, fantastic. No stars, so you get back to here. I'm surprised there's no ones. I would have thought there was at least, I thought this guy would say 1, you know? Like true, that is, for the print statements. I wonder if there are more simple examples of failure. Like, well, I tried like ABC versus DEF. Okay, no, it's able to, it's some able to look at the right side of the expression. Okay, even that's okay. So wait, which? It's something to do with the fact that the A and the A, like, it's the fact that they're so similar, I think. A versus AB, like. Interesting. Should I confirm that my tree drawing matches the expression, sub-expression, period block? So you have the overall expression, then the first expression, which has the A, no star, then empty, and then or another expression which has the A, then no star, and then the B, no star, empty expression, or which is empty because, yeah, that's within the, that's basically, that or is referring to this or. And then star for that particular sub-expression, and then no stars, then sub-expression number 3, so you've got 2, then 3, so 2 is this guy, so 3 would refer to this guy, 3 is the C, and then 4 is empty, it's this guy over here, and then or is that guy over there. So tree looks pretty good. So in terms of matching, I try to match this, I try to match this, I try to match this, we got the expression. I try to match this, I get the A. What is my code doing? What is my code doing? I've kind of forgotten, to be honest. I'm matching expression. I call match expression on this guy with the particular parent. This is the parent, by the way. Just in case that was required. Match the sub expression, text, expression sub parent. So we match the left, which is this guy, expression sub. We try to get the result, which I thought would be true. Why is it saying what? Okay, well, I think it's a single chart, and I think there's no... text pointer is equal to percentage %d, and char data is equal to percentage %c. I need to move the print statement down. Text pointer, and char data. Text pointer is 0, char data is A. I need to put a backslash in. Again. Okay. Text pointer is 0, child data is A. Okay, so that's that. Okay, notice that it never got the AB anyway. That's really interesting, actually. Just out of curiosity, did I reset the... I should be resetting, shouldn't I? In terms of the text pointer. Text pointer. And then, like, if this doesn't work, then shouldn't I be saying text pointer needs to go back to current text pointer? Like, I have to backtrack it, right? Try again with a different map with the other side. Ah, yeah, and that's because if I didn't do that, then this would still be pointing over here, and it wouldn't have worked. That's why text pointer is 1, char data is A. It's trying this. It's trying this side, but it saw the A and saw a B because I didn't reset the... okay. Ended up being a silly mistake. It wasn't even anything logical. I mean, it was logical, but it wasn't crazy logical. Alright, I've been avoiding it, but let's try the example with the star and the grouping. So, yeah, A, B, C, D star, A, B, C, D star. Let's use just C for now. I didn't even say what thing to think. A, B, C, D star, and let's just do A, B, C, D, A, B, C, D, A, B, C. Hopefully it's a little easier. Damn it. A, B, C, D, A, B, C. I think I should just call it. As in, of course, I'll debug this, but I don't want to do this now. I should sleep. Alright, we're getting there. We've got something. I don't know. It doesn't seem... It seems like the logic is like mostly there. It's just like a couple of strange... I mean, that last bug was just a bit annoying for me. Maybe I forgot to reset other places. It could be as simple as that, but I'll think better fresh. Text pointer is 0, A, 1, B, text pointer is 2, A, C. Text pointer stayed at... Look, text pointer stayed at 2. Child data became C. So it's definitely looking over there. Whoa, I didn't mean to do that. A, B, A didn't work. Text pointer stayed, became C. Then became D. A, C, didn't work. Interesting. So it tried A, which I'm assuming came from here. Let me try this again, but let me put it with an F or something, just so that it's like very different letters. A, B, A, C, D, A. A, B, A doesn't work, so we try C, D, it matches. A, B matches. A doesn't work, C doesn't work, so both options don't work. But instead of... Wait. What? 0, 1, 2, 3, 4, 5, 6. Child data becomes 6. Alright, now I'm confused. Why didn't it match? It seems like you guys did everything right. Alright, well, this logging is actually quite helpful. Now I'm kind of revitalized. Text pointer, char data. I just realized I forgot to say return false over here. Like, silly of me. Although I guess, yeah, I got caught over here anyway. Still, it's good to be explicit in the moment. Char data is this text string, text pointer. If char data equals dot or wait, what did I do? How did I handle the? I don't know if this is helpful. Yeah, it did this and then hit the empty sub-expression, text pointer became 7. So it would have returned true, right? Text pointer is bigger than or equal to the length. 1, 2, 3, 4, 5, 6, 7. Yeah. So this returns true. So backing out. Wouldn't this guy have returned true? Oh no, wait, this guy? Yeah. Wouldn't this guy have returned true? Text pointer is equal to this guy, char data is equal to x. We do that, it matched, so that's great. And then the x is matched, and then it returns this, it goes to empty, which is fine, it returns true. Did I write it wrong? I'm confused, like... I just went too far. Did it hit? No, I mean definitely hit this case because hit the empty, like it's printing this, hit the empty x sub-expression, text pointer is equal to 7. Return whether the text, just to confirm, text len is equal to oh wait. Yeah. They're the same number. So text pointer being greater than or equal to text len should return true, which means whoever printed this guy after calling again yeah, okay. I just put it inside the if statement to make sure that it matches and stuff. Of course it matches. It goes here, increments this to make it 7, checks this, returns false. I mean, it's going to return true, right? Because the next guy down returned true. Brrr. 5 minutes, come on. Hit the empty sub-expression, text point equals 7, text line equals 7. Huh? Text point equals 6, Charlie. Hit the empty expression, text point equals 7. I don't even know what's happening. Why is it printing it again? A, B, C, D. It's only printing the matches now, that's why it's looking like it's succeeding all the time. Maybe I need... I mean, it's a lot of recursion. Maybe I didn't handle the base cases well enough. Like, I don't know. I don't feel convinced by that. A, B, C, D, that expression would have called parent or CD, which would have failed as well, or empty, so then it matches sub up the tree. So let's see if this gets printed. Oh no, it doesn't run. Okay. Not fully confident if I'm okay. Normally I would use a debugger in this situation, but my debugger's being a bit weird. Let me just see if this works, because I feel like it wasn't working last time. What? Oh yeah, okay. So I was using it before. This guy, so it's just a dot out now. And the arguments are a, b, c, d, x, a, b, c, d, a, b, x. What? Okay. Breakpoint could not be obtained. That's a bit nuts. The debug will be very helpful. So it's a bit of a shame if I can't use it. If you've modified your source code but haven't rebuilt the application, is it not building it? Is that why? I mean, if I just compile it, surely that's good enough, right? But I'm assuming, I mean, obviously that's not good enough. Say C program, just to be specific. Oh, right. Yes, dash G. Did it work? G. Yes, that's I forgot about that. Okay, well at least that's working, and then I'll fix it up tomorrow. I'm not even registering what's happening. I just like watching the things change. Six. Okay. To B. These numbers are jumping around. What's happening? Original expression. Oh god. Okay, we've got to the 7-7 part, so that's like where the stuff is happening. Match. Right result is true. Okay. Bool result equals match expression. Okay, so it kind of figured out that it was true, like the right result is true. And then match the expression. Oh, I think I get it. Wait, now I'm confused. Did I do this really badly? So, matching the expression. If... Wait, no, this shouldn't... Why is this happening? Wait, there is a star, isn't there? Sorry. Yeah, A, B, C, D, that star. Okay, wait, so... I think, just based on what I've read... Was I looking at this the whole time? No, I don't think so. Anyway, I think what's happening is it figures out the A, B, C, D, and matches all that. And then I said, like, okay, when you reach the empty sub expression, don't return, like, keep going. Use the parent sub right child to keep going, and try to keep matching. So when I run match expression, when I run left result and match sub expression on the expression sub, maybe it's like doing everything already. Like maybe it's already. I'm tripping out, man. What? If subparent and not... whatever. I'll come back tomorrow. I'll lose the flow state, but I'll get it back. It's alright. I'm clearly not like in the mindset for it anymore. But we did okay, you know? Some cases work. It's just, yeah, I think the stars in brackets, I think, is where I think it's gonna be weird. Anyway, we'll figure it out.